Okay, so as we look at geometry, and these are the scenes, we're going to start with some of the basic concepts or basic understandings in geometry. And we start off with the point, line, and plane. Okay, these are considered undefined terms. They're relatively identifiable by most. And what we're going to do later on is we're going to actually define terms in geometry using these three things: the point, line, and plane. So the basics, the point. The point has neither shape nor size. You know, we're limited by our writing utensil to the size of it, but it is intended to have no dimensions. A line is composed of 2 points, okay? And a line is made up of points and has no thickness or width. It is one-dimensional, going in direction is some direction forward and back forever and ever. And then how do you represent that? So looking at this one example, there are many ways to write a line, and here's some examples using this. We have line M, so you have line with a italicized lowercase m. That would be identifying it using this. Line PQ is just saying, hey, I have a line with 2 points, P and Q. You could also have said line QP, because since this is that one dimension going forward and back forever and ever, it doesn't matter what the order is on your letters. So you could have PQ or QP. You can also have PQ with a line symbol over it, or you could have QP with a line symbol over it. So those are some of the basic ways to identify a line. Again, you have to be able to understand what a line, how you identify it, to where when you are reading it, you understand what is being presented to you. And then a plane is a flat surface made up of points that extends indefinitely in all directions. And there is exactly one plane for any 3 points not on the same line. Okay, and typically one of the planes that we have worked with up until now, is that X and Y axis. And we know that, as we travel down the X axis, we get infinitely large numbers. Travel up the Y axis, you get infinitely large numbers. And then as we go to the negative side, right, we would go to negative infinity, or going downward, we would go to negative infinity. So that coordinate plane is something that we've been using for a long time, and it just identifies something that goes on forever. Again, different ways to identify the plane. You have, excuse me, a capital script letter right here. So that would say, hey, plane K. That's what they're talking about there. And then we could identify plane width. Now, any 3 letters in any 3 orders, as long as they are not collinear. We'll talk more about the collinear and non-collinear things here in a second. And then, so as we have DBC, CBD, BDC, all of the different orders, because it would identify those 3 points. Let's see here. Space is identified as boundless 3-dimensional set of all points. Okay. And then collinear means that we have points that line up on the same line. So they line up on that one-dimensional line. They are collinear. As you can see here, if we talked about collinear, A, B, and C are collinear because they're on the same line. D and E would be non-collinear because they do not exist on that line. Coplanar, the same thing. We have what is presented here as possibly plane S or plane PQR, and these are coplanar because they all reside on the same plane. Now, if I took and I had point over here, point K, K is not coplanar. It does not exist on plane S, so that would be non-coplanar. Now, continuing on as we look at this, it says name lines and planes. So use this figure to name each of the following. So right here in a line containing point Q. Okay, now remember, in order to establish a line or identify a line, you have to have either have 2 points for the line, or you can also say line with the italicized letter, which would be C, because that is point Q. And I guess let me back up here and just say, hey, this line right here is what identifies point Q. So we do have line C, and just quickly I wrote in here, you could have line C. Of course, you could have line QT. Those are 2 points on there. You could have line TQ. You could have here line QT, line TQ, but you also have R sitting on this line. So you could have used R to name the line, and you could have said you had line RT, line TR, line RQ, or line RQ. So any of those names would have been sufficient, identifying the same location. And then a plane containing point S and T here. Okay, one plane that can be named is plane A. So if we look up here, we have a couple of planes going on plane A, and then sure, you want non-collinear lines. We can't use V. V is not presented on the plane, so anything with V is not an acceptable answer. We can't say plane TRQ because those are linear. So we would have to utilize point S in the name because S is not collinear with these others. So you could say plane STR, you could say plane STQ, just as long as you understand that you have to use something that is non-collinear in order to name the plane. So that's the big one there. So again, anything that would have contained point V does not count. So that doesn't count, that one doesn't count, and that one doesn't count. So here you go. So we have plane QST, and sure enough, QST are not collinear, so that would be a way to name that. So sometimes it's easier just to eliminate things that you know you can't use, and it will reveal those things that you can. Let's see here. So example number 2, modeling planes. So just understand that when we model things, we are assigning some form of geometric term to real life objects. So much like we may back in algebra have identified a parabola is sort of like a bridge, different things like that. So here, name geometric terms modeled by the objects, and I have them filled in, but understanding that, I mean, a book in itself could be a plane, but the edges of the book could be considered lines. A pencil or a pen could be identified as a line, and then a point, this quarter or this coin or something just sitting on a desk could just be a point. So just keeping those kind of things in. It says here that points in LK, they are non-collinear, so they could identify a plane. And then PQR, PRQ, QRP, those are collinear. So just understanding, using those definitions and carrying those forward. Now here, as we continue on with the intersections of 3 planes, so intersections of lines and planes, intersections of 2 or more geometric figures is a set of points that they have in common. So think about it here in this example. Looking at the coordinate plane, I have this point right here. These 2 lines intersect at a given point. So 2 lines would intersect at a given point. If I took a piece of paper, let's say I got this piece of paper right here, and then I took a pencil and I jammed it up through a hole, made a hole in that pencil paper, that would create what would look like a hole. So a plane and a line intersect at a point. So that would sort of be what that looks like. Thinking about a book, right? If I took a book and I opened it up, here's my spine. And thinking of the book, the top and the bottom of the book as they intersect, or where they come together, my book would form what would be 2 planes intersecting potentially, and this right here would be a line. So looking at, where do 2 planes intersect? Or if I look at the wall in the corner and I have the wall intersects with the floor at would be also a line. Think about, this is where the molding ad is on your floor, so that would be a line. So thinking about how these two things intersect. So that is understanding intersecting lines. So drawing geometric figures. So here we go. So we have here, it says draw and label the figure to represent the relationship. So they have given us all this information. Take a moment to read it. But QR and ST intersect at point U. So they have given you your points for Q, R, S, and T. We know that QR is a line, so that's why they connected those two. ST is a line, that's why they connected those two. And then they intersected at point U. So they've given you the coordinates, they graphed them, they did that. So it said there, graph and draw each line, done. Label the intersection, done. And then an infinite number of points are coplanar with Q, R, S, T. Infinite number of points are coplanar because right here, the coordinate plane goes forever and ever in all directions. So there is an infinite number of points that can be identified on the coordinate plane. But all are not all collinear, right? If I put a point over here on the coordinate plane, it is not collinear to those, but it is coplanar. So just understanding. Now this would be considered collinear, but a point over here is coplanar but not collinear. So that's what they're talking about. So looking at this next example, I'm going to fill it in real quick, but it says draw and label a figure to represent the relationship. Okay, so in doing that, it says line JK, right here, line JK intersects at point line JK, and line LM intersect at point P. So I went ahead and I graphed these points. JK, connected them with a line, of course, line going, arrows going in both directions, indicating that it goes on forever and ever. L and M, I connected those two, going on forever and ever, and they intersect at point P. Obviously, I'm not a machine, this is not drawn perfectly, but it's a good indication. And it says point Q is coplanar with these points, but not collinear with JK and LM. Here you go, point Q. What is coplanar but not collinear? All you have to do is pick a point anywhere. That could be point Q, that could be point Q, that could be point Q, this could be point Q. None of those are collinear. Now, if for some reason you said this, that is collinear, so that would not be accurate. It is coplanar, but they want something that is not collinear, so that would not count. So infinite number of choices where you could have picked something that was coplanar but not collinear. So there you go. So as we move on, interpreting these figures again, being able to identify, and this is a challenging thing for a lot of students and a lot of people in general, is being able to see a three-dimensional object on a two-dimensional surface. So what they have here is they have drawn in what appears to be we have a plane P, we have a line poking through plane P, we have a line that is intended to be sitting on plane P, and then this object right here. This object is intended to be a five-sided prism. We can tell 5 sides because the base has 5 sides. Prism sitting on that plane. So being able to identify, hey, how many planes do I have? Well, 1, and then here is 1, 2, 3, and then you have what appears to be the back side of the prism. And that's what these dotted lines are intended to show, the back side. So we have ended up having 6 different planes, and then they've identified them here, just understanding that, this prism ACD would be considered a plane. It's one side, flat side of the prism. So just using that as an example. And it says, name 4 points that are collinear. Well, there's actually only one spot that is collinear. 4 points that are collinear, sorry. Here I have H, I, C, and F all reside on the same line. So H, I, C, and F are collinear. Name the intersection of plane GAC and, here, let's see here. Let me do this. Let me erase that. Lord knows we don't want to see that right now. Big eraser. So we have GAC, which is GAC. They're intended that to be the back side of the prism, okay? The back side of the prism. And then it says, where does that intersect plane P? Well, it actually intersects right here along this segment, or this line of GC. So plane P intersects plane P in and plane GAC intersects plane P in, well, let's just go with CG, right? It's intersecting on that. It's in the form of a line. And then at what point do JI and DC intersect? Let's see here. JI and DC. They do not intersect, right? JI appears to go through the plane, and then DC is over here on the plane, but there's a big gap in between those two locations. So it does not. It does not appear that those lines intersect. DC lies in the plane P, but only at point I, where it intersects, of JI lies in plane P. So just that's what we're looking at. So here, looking at this, again, using those examples, I'm going to give you a second to look at that check, but I'm going to go ahead and answer it. So point ADB are collinear here. It says refer to the figure, name 3 points that are collinear. ADB is the only place where we have 3 points that are in line. So that's why ADB are my choices. You could have said DBA, ABD, any order of those 3 letters. But as you can see here, DC is not 3 points. And then, of course, here we could turn around and look at these. And we do have planes that are represented by 3 points, but they are not collinear. They're coplanar, so that is the difference. And you can't say that, well, DCI is collinear because we don't know. This line does not extend through that point, so we can't make that assumption. That's a big thing in geometry. We cannot make assumptions. So with that, I think we're almost on our last example here, and I would just say that I think some of the things, and then again, modeling is using, geometric terms and shapes and figures to identify real world things. So a biplane. So here we have a picture of a biplane. Has 2 main wings that are stacked one above the other. Struts connect the wings and are used for support. Flying wires run diagonally from the main body of the plane to the wings and between the stacked wings. Okay, so it says complete the statements regarding the geometric terms modeled by the biplane. Each wing models I'm going to assume they're trying to think of that 3-dimensional wing. So I would say each wing is modeled by a plane. Right, a plane. The wing is a flat surface. The intersections of the strut and the wing modeled since these struts are wires, I would say that is considered to be connected at a point. And then crossing the 2 flying wires models these guys intersect at a point too. So it's just a matter of being able to identify what those terms are, understanding the definitions, and I will just say that I would not use, I think there's some gaps in this image that could draw to question based on your understanding of what is modeled by those terms. So just keep that in mind, that we'll try to make it more precise to where there's no ambiguity in that. And one last thing, 3-dimensional drawings. Because it is impossible to show the entire plane in a figure, edge shapes with different shades of color are used to represent these planes. So sometimes hard to see in a black and white copy, but what they're trying to show you here is we have what could be, again, 2 planes are intersected, and they are intersected, or they intersect at what appears to be a line. So just keeping those things in common or understanding. So again, there's lesson 1-2, our points, lines, and planes. Again, this is intended just to supplement and help my students out. So if you have any questions, please let me know in class. But again, this is just a supplemental addition to our lesson.